Hello guys, this is the beginning of a series on several basic skills you all need to get down in order to be comfortable doing physics in the very near future. We will start with the standard method to solve simple algebraic equations, usually linear ones. There are several strategies that you can use to solve this sort of equation. Obviously, we all base these methods on a very simple principle, which is everything you do on an equation you do it on both sides of it. This is actually very important. So, for this example, we may want to start by adding 16 on both sides of our equation, in which case we get 3p plus 16 is equal to 7p. Because 16 is added on both sides, therefore it gets cancelled on the right hand side. After that, we may want to subtract 3p on both sides of the equation, and this results in 16 is equal to 7p minus 3p, or 16 is equal to 4p. Notice that it is perfectly fine to have the unknown variable on the right hand side of the equation. That does not detract from your method. After that, we can divide on both sides by 4. In that case, the left hand side becomes 4 and the right hand side becomes p. So this has given us the solution p is equal to 4, just as was expected. And once again, the takeaway from this example is that we can leave the variable on either side of the equation. A similar situation would be to have the product with some additions or subtractions inside of a parenthesis. In that case, we have at least 2 different methods to solve this. For example, we may want to use the distributive property from basic arithmetics, in which case you will end up with 2m minus 8 on the right hand side. After that, you can just do all steps analogous to the previous problem. You can subtract 2m on both sides and you have 2m is equal to negative 8. Then divide by 2 on both sides, which gives you m is equal to negative 4. But there is an alternative to that method. You could start by dividing at the beginning by 2. And in that case, you will have 2m is equal to just m minus 4. If you now subtract m on both sides, you get m is equal to negative 4, which is exactly the same answer that we were looking for. So, in this case, the main takeaway is that there may be more than one way to operate. In the next example, we want to demonstrate first what would be a wrong way to solve this equation. Very tempting to just think that you are going to divide, and so x will be equal to 48 over 96 or 1/2. I will show you why. When you have 96 over x and you divide by 96, what you get is 1 over x, not just x. Therefore, you have not really solved the equation. In these cases, where you have the unknown variable in the denominator, the very first thing that you need to do is to multiply times the variable. In this case, times x. When you do that, you are left with 96 is equal to 48 times x. Afterwards, you can see that the direct process consists of dividing by 48, and that leaves you with 2 is equal to x, which is the correct answer. So, I will say that in this case, there are two takeaways. The first one, sometimes you need to move the variable from its original position. And the second one is you shouldn't really underestimate the complexity of your equation just because of its size. And what I mean by that is that it doesn't matter if the equation is short or long. Even very basic, very simple equations can have important, non-negotiable steps that you need to take into account. For the next example, I want to talk about operations that need parentheses and operations that do not need them to indicate the order in which things have to be done. In this particular case, something we can disregard is the presence of parentheses for these integers. For p, because it does not add any useful information for the operation. The given equation is exactly equal to the one that I just wrote. However, it is important to understand that solving this equation for the variable r has a very specific order in which arithmetical operations need to be done. Let me show you a ground solution. You could think that you want to take the square root of this. You could also think that this square root is equal to 4 plus 3. And you will conclude that r is equal to 7. But that approach is wrong. The actual order in which you need to do this is as follows. Even if you take the square root, you still have an addition of the two terms inside of the square root. This means that before you operate the square root, you need to operate all the indicated operations inside of it. So this is equal to 16 plus 9 inside of the square root, or square root of 25. This gives us a final answer of r equals 5, which is the correct answer. So I will say that the main takeaway from this example is that there is a specific order of operations that cannot be altered. Finally, for the last exercise, I want to show you an equation that can possibly become a little complex if we do not pay attention carefully, and if we do not consider that there is more than one possible method to solve. This example can be solved in two ways. In the first case, we can take the greatest common denominator, which is 6p, and multiply the whole equation times 6p. This results in the equation 3p equals 6 plus p. After that, we can just take some standard steps. 2 times p is equal to 6. Divide by 2, which gives you p equal to 3. That is one possible method. You could also decide to subtract 1/6 on both sides of the equation, leaving you with 1/2 minus 1/6 is equal to 1 over p. The subtraction is of course equal to 2/6 or 1/3, and that is equal to 1 over p. That leads you to p equal to 3, which is of course the correct answer and corresponds with the first solution. So, the main takeaway that I want to emphasize from this is that even if you use different methods, they will give you the correct answer as long as you follow them properly. I hope that this series of examples gives you some strategies that you can use in order to solve more complex equations that you will surely encounter during your physics learning. Thank you for your attention, and I look forward to making more of these for you. See you later, and until next time.